In this video, we will take a look at how to use Exploratory for predictive analytics. The type of predictive analytics we'll be looking at is time series analysis, or how to predict out a pattern or a set of data into the future. We will take a look at data wrangling, having to do with creating of a time series, the visualizing of a time series, and look at the actual prediction. In this walkthrough, we will be actually looking at carbon emissions data from 1651 to the present. There's some data manipulation we'll have to do with this data. We're going to have to discard some data before 1958. We'll have to create a new column, a time series column, to do the time series analysis. And then we will take a look at creating a forecast using the time series forecast function in Exploratory. We will then plot the year by forecast and the actual data. So let's get started. I will be performing the walkthrough of predictive analytics in the new Exploratory project, and subsequently we are in a new Exploratory project called Demo Predictive Analytics. We'll be working with carbon data, and so I'm going to click on the plus sign right next to data frames, and I'm going to be working with some file data that's present on a remote server. It's a CSV file, so we're going to click on text file, CSV_delimited. The remote file URL is present in the linked to text files that is uploaded as part of this Exploratory module. After pasting the remote file URL or typing the remote file URL in, we can click on OK. And the data is imported into Exploratory. Taking a look at this CSV file, we see that it has a header, 2 columns, starting at 1651 and running all the way down. We don't see all the rows yet, but there doesn't really seem to be any problem with the data so far that we can see. So let us click on Save. And so we have the data set carbon_1651_present. I'll be deleting the source and be clicking on Create to create a data frame, and so we have our data in the form of a table. Now, one of the things to notice about this table is that while our data frame is supposed to start in 1651, and it does start in 1651, the values of CO2 emissions for 1651 and subsequent for years all the way running up to 1750 is 280. It seems like this is a problem in our data. And so one of the things we might actually want to do is skip this year range from 1651 to 1750. And then we see this large jump where our data actually starts, which is 1959. So the first thing we're going to do is we are going to filter our data to make sure that we're using the right data for our predictive analysis. So I'm going to create a filter, and my filter is going to pick values greater than, and I want to look for values greater than, in fact greater than or equal to 1959. And so I'm going to be typing in 1959, and if I run this, I will get values for year where the year is greater than 1959 all the way up to 2016. To perform a time series analysis, one needs to make sure we have a column in the date time form. Unfortunately, both our columns right now are numeric columns, and so we need to take this numerical version of year and convert it into a date time representation of year. Here's how we can attempt to do that. We're going to add a new step, and we're going to create a calculation. I'm just going to call this calculation date time. And so I'm going to create a new column, and in this column I'm going to run a function known as paste. Paste is a function that works like the SQL concat function. The SQL concat, or the concatenation function, concatenates multiple values together, and paste works similarly. In this case, I will be pasting the value of year with a value of month as 07 a value of day as 0, 1, and a time of 0, 0, colon 0, 0, colon 0, 0. Once I do this and click on the Run button, I have a column called DateTime that looks like it has a year component and a time component. This, while it looks like a DateTime column, is not actually a DateTime column because it is right now a character column. I can click on the down arrow and change the data type of this column. I can convert it to a DateTime column, and in this case, my DateTime column has a year, it has a month, it has a day, and an hour, and a minute, and a second, and so option I can pick in terms of the way the data is structured is year, month, day, hour, minute, second, and if I select that option, I'll be overwriting the existing column with the DateTime version of that same column, giving me a DateTime column in the DateTime data type. This now allows me to perform a time series analysis. To perform a time series analysis, I will be adding a new step. I'll be running analytics, and the analytics I'll be running is a time series forecast. I need to specify two columns, a date time column, and in this case, because I have only one date time column, I'm going to leave that as it is. And since I have data for CO2 emissions for a year, I'm going to leave this as year. If I would like to change that, if I have, for instance, monthly data, I can predict out for every month, I predict out for every day, week, so on and so forth. But since I have yearly data, I'm going to leave it at the year level. The value column in terms of what I'm trying to predict is going to be CO2. Now, the function right next to CO2 is sum in the sense that it is going to aggregate CO2 for that year. Because CO2 is one value for the year, the sum is going to give me only that value for the year. And I need to set up how many cycles or how many time periods do I want to predict CO2 out for. In this case, I'm going to leave the default in place as 10. If we would like to have some seasonality or time varying components as part of our model, we can set those up as well as part of the options or parameters right here. Since I don't have any yearly or weekly seasonality, I'll just leave the defaults as they are, and I can click on Run. Once I click on Run, the time series analysis creates a forecast where it looks at the daytime value, the actual CO2, and develops forecasted values for CO2, high, low, trend lines, and so on and so forth. More importantly, since I have predicted out for 10 cycles, we see at the bottom of our data that ran till 2016 now has 10 more rows, 17, 18, 19, 20, 21, all the way up to 2026. And so, while we don't have the actual data for those, which is why we have NAs right down all the way here, we do have predicted values of, or forecasted values of CO2 for these 10 years. And so we have now created a time series forecast for CO2 from 2017 to 2026 based on the trend that our data actually had. To represent this, we might go to the chart, and we will be working with a line chart. In our case, our x-axis, because we have time data, is going to be a date-time data type. And in our y-axis, we're going to try to represent two lines. We're going to represent the forecasted value, or what is the predicted value of CO2 over time. And the second one is the actual value of CO2 over time. And what you will notice is that the forecasted value overlaps very closely with the actual value of CO2. This tells us our forecast is in line with actual observations, and so our trend line seems appropriate out over the next 10 years. This is how one can use Exploratory to perform a simple time series forecast. Thank you for listening. Please let me know if you have any questions.